Firstly, we've got the database storage layer, and this is like the mailroom. It's designed to efficiently organize and store lots of different types of letters and parcels arriving from many different places. Some parcels are very large, some are very small, and some are just regular letters, but they must all find their place in the mailroom. And that's very much similar to Snowflake, receiving large batch structured data, near real-time semi-structured event data. Everything ends up in this tier within the architecture. Next up then, we've got query processing, and that acts like the courier. So it handles the logistics of taking the mail from the sender and working out the quickest and most efficient route to deliver it. Once delivered, it can obtain a response and return it back to the sender. Now, this is very much in a Snowflake land. You need compute to be able to go and find the data that you need, retrieve it, process it, and give it back to the person or application that's called it. Now, the virtual warehouse provides the resources to allow these deliveries to take place. And so this is very much like the delivery mechanism, because the virtual warehouses, as you'll find out in the next domain, come in various different sizes, known as t-shirt sizes, small, medium, large, and so on. In the postal service analogy, the delivery mechanism used might be a van or a truck. For international items, it might require something like an aeroplane. Next up, we've got the cache, and that's set up for those addresses which regularly receive a large amount of post. They're kept in easy access for fast retrieval. This is known as the cache. You'll be familiar with this if you've seen it before. The most important point to note at the moment then is your database storage layer and your query processing layer is completely independent of each other. They are not tightly coupled, and that means that your database storage can be scaled independently of your query processing, and you can scale up and down your query processing depending on the workloads that you've got, whilst the database storage layer remains the same and your data is always available whenever you need it. Now, finally, we've got a cloud services layer, and you can almost think of this as the big boss or the CEO. It's the end-to-end tracking system providing oversight across all of the services that we've mentioned so far. It ensures the post is secured for access when in transit, and it keeps all the lights on within the infrastructure behind the scenes to ensure the post reaches the destination within the guaranteed timescale. Now, just keep this metaphor in mind as we look at each of the services in a little bit more detail in the following slides. Understanding how these features work together and complement each other really helps when thinking about how to design efficient solutions on Snowflake. Snowflake, when it receives data and you load it into Snowflake, it stores it in a compressed native format within micro-partitions. Now, these micro-partitions are small blocks of storage between 50 and 500 meg uncompressed, because note that once it goes into Snowflake, they end up even smaller because Snowflake applies its own native compression algorithm. So if you've got a very large table, you're going to have millions of these micro-partitions scattered across your data storage layer. So how does Snowflake organize this data? Well, Snowflake automatically selects a clustering key based upon the data as it's loaded. Metadata is then collected and stored, and that allows the query optimizer to understand what data is contained within each micro partition, and that allows for very fast retrieval of data, and we'll go into that in a lot more detail later in this domain. Now, the query processing layer, this provides the resources to execute the query by using a virtual warehouse. Now, a virtual warehouse, essentially, it's a basket of compute, so CPU and memory and RAM, required to run pretty much any SQL data manipulation language, DML, operations against the data in Snowflake. That also includes loading and unloading data into Snowflake's tables. And we'll see in the next domain, virtual warehouses come in a range of t-shirt sizes, as I mentioned earlier, from extra small to various large sizes. Virtual warehouses can access any of the underlying data in Snowflake. You can also start, stop, drop, and create them as you need them with no impact on the underlying data or operations within Snowflake. Finally then, cloud services. As I mentioned, there's no need to go into this in much more detail, but we will touch on various aspects a little later in the course. But this is the layer, if you remember, the head office of the postal service, the brains of the operation, and it's a collection of services. So it includes authentication, and this manages the service that allows users or applications to log on to the Snowflake platform. It also includes infrastructure management. So this is handling compute nodes and storage buckets behind the scenes based upon whoever your underlying cloud provider is, which you're running Snowflake on top of. You've got metadata management. So the service collects metadata when various operations are carried out within the Snowflake platform. And then you've got query parsing and execution. So this service takes care of the query planning to work out the most effective and efficient ways to process queries. It also compiles the queries to make sure there's no errors and manages that end-to-end query execution. Snowflake uses what's called a cost-based optimizer, and that looks to determine the fastest path to access the data to satisfy the query, looking at a range of query plans based upon the metadata available. And that's known as query optimization.